Now the third one, we're going to use cell-based input. Okay, and what we're going to do is select the input cell, which is D9. Okay, so here what we can do, this is one possibility, so it'll go through, from the cell value, right? Minimum of minus 10%, maximum of 10% in steps, in 7 steps. Okay, so that's the number of scenarios that at risk will generate. Or we can select values from a table. So we can give a list of values like 6, 7, 8, and 9, right? And we can give a name for that. Admin price 6, right? Admin price 7, and admin price 8, admin price 9. Okay. So now these are the 3 inputs that will be used to generate the scenarios. Okay, and then you can go to additional options. You can select where the results of the simulation analysis should go. The default is a new workbook, so a completely new workbook will be created. Or you can say, okay, active workbook, and you can say where, select active workbook, then new sheets will be added to the active workbook. So we'll keep the default. Then you also have the kinds of reports that we want to generate. So we have, let's select these 2 as well. Okay, so now you can save and exit, in which case the simulations won't run, or you can click analyze. So it tells you how many simulations it'll run, and in each simulation how many iterations will be performed, and asks you whether do you want to proceed. So it's going to be 10,000 each time and 18 simulation. So a total of 180,000 iterations will be run. So click OK. So at the end of the simulation, you see a new workbook, and it's not been saved, so you can save this workbook. And you have a bunch of sheets. So you have a summary report. Okay, so here are the different values considered for increase in movie per month, and then sensitivity, and then the 4 admissions price. And then gives you the cell where it goes, and then here is the output. So you have the for each scenario, okay, percentile 1%, 5%, 20, and so on. So you get the mean, minimum value, maximum value, mode, and the other summary statistics. Of course, summary statistics like this is kind of hard to make sense out of. So it's, graphical output is a lot more understandable. So we will get to that. So then you have a compact report. Okay, so here we have some charts. Okay, that may be useful, but these charts are repeated elsewhere, as we will see. So here we have the total profit, okay, and the cumulative probability at each level. So what is the probability of profit of minus 50 million? And then as the situation increases as you go to minus 40 million. Okay, so the probability increases in a cumulative fashion. So that's your first percentile. And if the input is set at uh, fifth percentile, then the same chart starts off like here and then goes up to there. So you get a picture of what is the probability for a particular level of profit. Of course, here they're all losses. So you can be here. Okay, you can, if you look at that part for if the input turns out to be at the first percentile, then there is a near certainty that your loss will be in the 40 million range. And for 99 percentile, so there is a near certainty of almost 100% of a loss of only 20 million as opposed to 40 million. So that's the sensitivity analysis report for movie per month with pass. Then the same chart with consumer sensitivity. So as consumer sensitivity changes from the first percentile all the way through 99th percentile, and how does the cumulative probability chart for the total profit changes. And then for the four admission price of 6, 7, 8, and 9, and how does that affect the cumulative probability for various levels of profit. And then we have percentile graph. Okay, so here again for the two input variables. Okay, so you get from 0 to 100 percentile. Okay, so here are the percentiles that we tried. Now, how does the total profit change? A percent change graph, and this is what is called the spider graph. So once again, you start with the base level and then change from base value, and we did not select a base value, so at risk automatically selected a base value, but you can set a base value of whatever it may be. So it goes back about 10, 20, 30, 40, 50, 60%, and on the negative side, on the positive side, from the base value, and then looks at the output. So here we have increase. The blue line is for increase in movies per month, and the orange line is for consumer sensitivity, how the profit changes as the input value changes in percentage wise, either on the lower side from the base or the higher side from the base. And the gray is for admissions price. And then we have box plot again for profit. Then this one is for movies per month, increase in movies per month. So at the first percentile level, 5th, 25th, and so on, and you have a box plot for the range of profits that we generate out of. For each one of them, remember there are 10,000 repetitions, and you have 10,000 profits that range in this fashion. Same thing for consumer sensitivity, and then for the four values for the admissions price. Then we have the tornado graph, where we have the three inputs. Okay, so this is where you go from the lowest possible value to the highest possible values in increments of 10 percentile. And how does the profit change? So here, cell D5, that's your admissions price, and then increase in number of movies per month, and then the consumer sensitivity, and they all, it looks like about the same variability as the others.